Hello and welcome to another CCNA lesson where we're going to learn about how our end devices acquire IP addresses through a protocol called Dynamic Host Configuration Protocol, DHCP. You can think of DHCP, the analogy I have is that you have a car and it has a VIN number, right? The car has a VIN number, and you want to be able to drive in your state or your town without, breaking the law because you need a license plate. You already have a driver's license. You need a license plate. You have one form of identification. Your car has its own form of identification in the sense that it has a VIN number. And then you go to the DMV and then you acquire a license plate, right? Because they have verified that you have this VIN number. The VIN number identifies the car, the color of the car, when it was manufactured, who manufactured, so on and so forth. Similarly, you can use that analogy in comparison to your vehicle, which is your end device, your phone, your tablet, your Ring camera, and so on. Those are all end devices. And those vehicles communicate with each other. And they have unique identifiers called a MAC address. The MAC address also similarly identifies, the manufacturer, and it is a unique identifier for this device. And it wants to communicate. In order to communicate, you need an IP address. So we're on, and the network it wants to communicate on is 192.168.1.0/24. Right? And let's say on this network there are 200 and some odd end devices. Let's say we have a desktop here and a laptop, another desktop. In this case, we're just going to represent a small subset of this network, right? And each one of these devices wants an IP address. And we know on this network we also have a very old 2960 Cisco Catalyst switch, 24 port. And our end devices are connected to this switch with a fast Ethernet copper cable. All right. So how can these devices acquire IP addresses on this network? Well, we can manually go to this, let's say this desktop with its name, and we can statically assign it, which means we'll manually type it in like so: 192.168.1.5, and subnet mask is /24 subnet mask, and maybe a default gateway if it has one. We'll say 192.168.1.1. Okay, so here we are. We assign its IP address statically, manually, right? Or we can dynamically. But how does that work? Well, similar to you going to the DMV and making a request, we can have our end device make a request to an entity that can give us what we need to communicate, or if you were a car, to navigate, to be able to legally drive on the roads, right? To be and have an identifier like a license plate. Well, our license plate will be our IP address. So how do we do that? In order to do that, we need a dynamic host configuration protocol server, a DHCP server. So here's a server. The server itself will have an IP address, 192.168.1.2, let's say 2. And, we don't have a router, but let's say if we did, it would be 192.168.1.1, right? And now we can go to a service on that network, in this case, a DHCP service. Now, in Packet Tracer, you have your, if you selected this server, you have, different services. You have email services, you have DNS services. We have a DHCP service, Dynamic Host Configuration Protocol service. And what its job is to assign IP addresses when they are requested of it. So our network is 192.168.1.0. Starting with when you have a DHCP server, you get to choose where in your network you want to start assigning IP addresses. I'm going to start from 3. Okay, I'm going to start from 3, and I'm going to, let's say I had a router, let's say 192.168.1.1. So once an end device makes a request, I want to let it know that this is your default gateway. And let's say, we'll assign Google's server as our DNS server, right? Any domain name resolutions, go to Google, resolve it that way, right? and I'm going to turn it on. So now it's on. So the server has an IP address. Our DHCP service is configured to assign IP addresses, save, and now let's find out whether this actually works. Well, wait, I forgot one thing. I forgot to connect our server to the network. It won't communicate with anything if it's not connected. All right, so it's going to take a moment to connect because it's a spanning tree, but just give it a moment. It'll come online. In the meantime, let me go and configure our network interface card on this from static to DHCP. Now, the moment I select DHCP, there's a process that happens. There's a request process. This device will make a request. It will send it to the switch, and the switch will broadcast it to every port that has an end device except where it came from. One of those will be to the DHCP server. Everything else will say, well, I'm not a DHCP server, not me. The DHCP server, in this case our DMV, will get that request and say, oh, I can offer you an IP address. It will respond back and say, yes, I can offer you an IP address. And the end device will request an IP address. So it made that broadcast already. It requested an IP address, and the server offered it 192.168.1.3. In addition, it gave it the subnet mask, the default gateway that we specified in it, all the other configurations, 8.8.8.8 being the DNS, right? That's what we configured on the DHCP server. Will the same thing happen over here if I did it again? Any guesses? If you said yes, you were correct. Okay, now what about this one that has a static IP? What can we change it back to DHCP? Of course we can. It got the same IP because 3 was taken, 4 was taken, and naturally this was 5. So it gives you the next available IP. Okay, so I would like you to just think about the problem that this solves. A DHCP and a DHCP server in this environment solves the problem of having to manually, if you have the /24 network with over 200 IP addresses, 200 end devices, you would have to manually configure each one. Maybe you have an Excel spreadsheet and manually type it in each time and know what's where, and if things change, you have to update it. It can be quite the task. This is an example of how this task has been automated to be more simplified, more efficient, less error prone. Thank you for your time, and I hope this helped you understand better and prepare for your CCNA.